Hello classmates and professor, this is Jonathan Ramirez from Team 2. I have designed here, or I wired up the anti-aliasing and anti-imaging filter with two buffers. So we begin in the circuit from this side, and we go around the IC like this. So you allow me to show you really quick. This is the IC I'm using. This is the LM324, I believe Texas Instruments, and it has 4 operational amplifiers. So I am beginning from here and working my way around using the 4 amplifiers in that way. I am using other values for the design here in the course project requirements. I do not have all these values, so I use different values. For R2, R3, R4, and R5 I used 12k ohm resistors. For C3 and C2 I used 100 nanofarad. For C2 and C4 I used I believe 10 nanofarad. Yeah, I used 10 nanofarad for that. For C1 I used 1 nanofarad. For Q1 I used a JFET 2N5458. Let's see. For the digital clock here, I am actually going to use my power supply, Elenco, and I can set it here to square wave, and then adjust my frequency here. So it would probably be, I believe it was 8 kilohertz. But I still have to get the actual. And then here I can find adjust, and the amplitude is here, and then our DC offset. But I will use this precision timer in case I need to basically make our signal, or our clock, our digital clock, a little bit neater or cleaner. But my power supply actually supplies a very neat waveform. So here is the circuit once again. I'll explain it quickly. So the input would be here, and this would be our analog input. As you can see, the analog input here, and that analog input would come from our power supply. And then you can see here we have our resistors in series here, and then our capacitors in series here, and in the middle they meet in a crossroads as they do here. Let's see, so resistors here, capacitors here, and they meet in a crossroads, so all 4 of them are parallel. And as you can see, so this pin here is output, this pin here is negative, and this here is positive input. This is our ground. You can see it's grounded on the red line there. Our capacitor here is grounded here. So our output goes from here to the positive input of the second op amp, and then our capacitor, our larger capacitor, and the input is also connected to the positive input, as you can see here. See, the output here is connected to the input of the first buffer, the positive input, and also the largest capacitor in our input is also connected to the positive input of our first buffer. Moving on to the next capacitor, the next operational amplifier here. This is the positive, negative output, and as you can see here, this wiring is very simple. We have no components. It's just a negative lead here connected to output. So you can see here, negative here connected to output here, the green line there, and then this here is our output line to our transistor, our JFET transistor right there. Well, I'll explain here. The drain is the first line here, the source second line here, and I think the base is here. Let me see, I can show you guys. Here is this. Here is the one I'm using. Oh, I'm sorry, the gate. The drain, the gate, and the source. And here's an image of that I was using just to keep myself. This one right here. So we can see here our drain, our source, and our gate. Yep. So drain, first line, source here, gate here. And if we go back, we can see that our drain is connected to the to the output of the first buffer, and our source is connected to the our first resistor input to the positive input of our second buffer, and there's a capacitor parallel to that to basically alleviate any ripples that we don't want, or basically get rid of them. And then also our gate is connected to from our source in our JFET. We have a resistor going into the positive input of the third transistor of the third op amp. Sorry. The third op amp is the buffer. The output of the third op amp here is wired to the input, the negative input of the third op amp. As you can see here, it is also connected to this first resistor here. Actually, this is R4 and is in series with R5. These two capacitors are in series together, but they all meet at this crossroads in the center. As we can see here, they're in series, these are in series, but they meet at a crossroads, so they're all parallel. The smallest capacitor is connected to ground. This end of the resistance line is connected to the positive input of the last op amp. The larger capacitor is connected to the output of the fourth op amp. As we have seen in the other operational amplifiers, the negative input is connected to the output of the op amp. This line here is our positive input voltage, our voltage source for the op amp. We will collect our output from a wire similar to the one I have here. For the sake of showing you, I will put it here, and that would be our output. We just connect this to our oscilloscope and get a reading. This wire here is connected to our power source, which can generate a pulse, and I think, oh yes, our ground wires. Our ground wires here connected to the red line there, ground wire here connected to that line there, and that's about it.